All right, and here's our first example on how to use the p-value approach to a hypothesis test. So this example reads, the Center for Disease Control and Prevention reported in 2010 that 20% of Americans smoke tobacco. A random sample of 400 Americans was found, and from that sample, 76 reported that they smoked tobacco. Test whether the population proportion of Americans who smoke has decreased since 2010. Use a level of significance of 0.10. So there's a lot of things to unpack here. I definitely recommend using a highlighter or underlining things. That's what I'm going to do. We are also going to write down a lot of our important information off to the side before we even jump into the steps that we need to do to complete this problem. So let's see. They reported in 2010 that 20% of Americans smoke tobacco. They took a random sample of 400 Americans, and 76 reported that they smoked tobacco. We are going to do a test. I like seeing that word because that tells me I'm doing a hypothesis test. This problem was nice enough to give us the word population proportion. We want to see if that proportion has decreased, and then a level of significance of 0.10. That is our alpha. That's what we're going to compare our p-value to determine whether or not we want to reject this null hypothesis or not. So I'm going to start by taking all of the numbers that I underlined, and I'm going to write them off to the side. So I have 20%, 400, 76, and 0.10. And I'm going to identify the symbol that each of these represent. This is going to help me as I build my null and alternative. It's going to help me if I'm doing this by hand to fill in that z-score equation. If I'm doing this in Excel, which unless a problem specifically tells you to do something by hand, you are more than welcome to use Excel. It's also going to help me when I go to do that conclusion. So I'm going to start with what I find easy. So a sample of 400 Americans. They sampled 400 people, so that's my sample size, which is N. A level of significance of 0.10. Anytime I see level of significance, that's my alpha. Level of significance and alpha are the same thing. So I'm just going to put a note for that here. Level of significance. Because I'm saying alpha says anything less than 0.10 is too small. So again, alpha serves as like a cutoff value to say, hey, if it's less than this, that's when you're going to reject. That's when your P is too low. So you reject HO. 76 is the number of people from the sample that said they smoked tobacco. That would be my X. And then the tricky one for me was the 20%. That's what was reported in 2010 as the percentage that smoked tobacco. So it's a percentage. So that's either going to be P or P hat. It's a proportion. And then it's a previously reported. So that's going to be my P. I'm going to assume that that's the percentage that are smoking now, and then we're going to see if that has decreased since then. So the first thing I'm going to do is I'm going to write out my null and my alternative hypotheses. So always start with an HO and an HA, a ho and a ha. Ha ha ha. Okay, I'm sorry. And then we are looking at proportions. So that's going to be P, and it's always P equals. And then we don't want to use percentages in our null and alternative hypotheses. So I'm going to write 20% as 0.20. And then our alternative is also going to be P because we're still looking at a proportion. I'm just going to rewrite that. And then we want to see if the proportion has decreased since 2010. So I want to see if P is less than 0.20. And so that makes this a left-tailed test because it is a less than symbol. So I might want to remember that later. So now step 2, I'm going to calculate my test statistic. Oopsies, I'm spelling statistic wrong. That's embarrassing. Statistic. So your test statistic is your z-score. So as a reminder, if we're going to do this by hand, which we are going to do it by hand, and then I'm going to show you how to use Excel to do this. When we do this by hand, the z-score formula is p hat minus p divided by the square root of p times 1 minus p over n. So I have p, n, x, and alpha. I don't know what p hat is, but I have the information I need to find it. So I'm going to find p hat. Whoa. Remember, p hat is x over n. So 76, I don't know what's happening. I'm sorry. 76 over 400. 0.19. So p hat is 0.19. P, if you aren't sure what happened to your p, go back and look at your null. Sorry. This p is always going to be the same number in your null hypothesis. Same thing down here. These p's are always going to be the number from your null. So then to do the z-score, we're going to take our p hat that we just found, 0.19, minus the number that's in the null, 0.2, divided by the square root of 0.20 times 1 minus 0.20, divided by 400. So the top part is negative 0.01. Be careful with all those zeros. And then the bottom, I have to do this with you guys because I don't actually know what it is. This one turns out really nice actually. We don't have a repeating decimal. This one is 0.02. So we do that division and we get negative 0.5. I'm going to keep going. I'm going to do step 3 by hand, and then I'll come back and I'll show you how to do step 2 and 3 at the same time in Excel. And then we'll do step 4 last. So once I have my test statistic, I need to find the p-value, and that's going to be a probability. And one of the things about these hypothesis tests that I have failed to mention so far is that we always want to make sure that we have a normal distribution. Now, part of that is going to come in the process of collecting your data. So in the larger 4-step process of stating your claims, collecting your data, assessing everything, and then coming up with a conclusion. That second step where you collect your data, you look at your graphs, you look at your charts, you do all that stuff, part of that step would be looking at the central limit theorem and making sure that you have a normal distribution. If you don't have a normal distribution, you can't do a hypothesis test. So that's one thing to remember, is that all of these hypothesis tests that we're going to be looking at depend on a normal distribution of your data. Everything that I give you is going to be normally distributed because I want to see you doing all of this. In the real world, you have to check that. You can't just assume that it's going to be normal. You have to make sure that it actually is going to be normal. So I'm going to find this p-value, which remember is a probability. And this is a p-value based on something that is normally distributed. That's why we use the z-score. So we're looking for the probability. We have a z-score of negative 0.5. So let's write a few things down actually. And again, I'm going to do this by hand. So my z-score is negative 0.5. And what I need to know, thinking back to how we calculate probability with something that's normally distributed, we find the z-score, then we would draw the curve and shade the curve. You don't have to do those steps if you don't have to. If it is still beneficial for you to draw the curve and shade the curve, then go ahead and do that. So I'm going to draw my curve. It helps me. I like doing this step. Here's our z-score. If this middle step here you don't have to do to be able to do the problem on your own, then you can skip this step at this point. And then I need to know where to shade. Am I looking at everything less than or everything greater than? And we find that answer in the alternative. The alternative says p is less than 0.2. So the alternative is less than. So I'm looking for everything less than. So I want to find the probability of being less than a z-score of negative 0.5. So in Excel, that would be norm.s.dist negative 0.5, comma, true. And I don't have the answer in front of me, but give me 1 second. I have it on my computer. Nope. .3085. Well, we will check that and make sure that that is true in our next part. So this is how you would do the z-score and the p-value by hand. So my sample results came up with 0.19, or 19% of my sample said that they smoked tobacco, which corresponds to a z-score of negative 0.5. And the probability that less than that of people that smoke is 0.3085. I have a file in Excel that will do all of this stuff for you. So I'm going to open up that file right now. I have to do this first. So this is that file. I'm going to open it next to it actually, but I had to do this first. Here we go. Here's this file. And the second page down at the bottom will take you to how to do a hypothesis test for proportions. And I have a whole video that explains all of this stuff. So what we're going to do is we're going to type in 0.2 to this first spot, maybe. There we go. And then 0.2 here. And then this is doing right-tailed, so I want to change it to left-tailed. So HOP equals 0.2, HAP less than 0.2. There's a menu here where you can change these. And then I'm going to enter the numbers that I wrote down off to the side. So my N is 400, my X is 76, and my alpha is 0.1. You don't really need the alpha for what we're doing. The alpha is necessary if I were teaching you guys the other approach besides the p-value. There are other teachers that use that method, which is why we have it in the spreadsheet. We don't really need it. So if you're going to use Excel, the test statistic is calculated for you. In these orange sections, we see p hat is 0.19. That's something that Excel calculated for me. I didn't have to do that. So p hat 0.19. Excel gave me that. And then we have the z with the 0, negative 0.5. Excel also calculated that for me. I didn't have to do that. That saved me a whole lot of work. That is the hardest part of this entire thing, is making sure that you get that z-score correct because of all of those decimals and the square root, and oh, it's a lot. And then down here, step 3, Excel also found that for me. P-value, 0.3085. In 30 seconds, I just did what took us like, 10 minutes? Way too much time? But now we know where these numbers are coming from. Oops. So I'm just going to keep that off to the side there because we're going to need it again. So here we have steps 1, 2, and 3. So the last thing we need to go ahead and do is go ahead and create our conclusion and interpretation. I need to insert a page, but that's not where I wanted to insert the page. Okay, hang on, that did not work. Maybe it'll work here. Okay, there we go. Now it worked. So I have my null and alternative, my test statistic. I did it by hand and I used Excel. You can do either or. You don't have to do both. Do it by hand if I tell you to. If I don't tell you to, please use Excel. P-value, again, you can do it by hand or using Excel. If I tell you to do it by hand, you must do it by hand. Otherwise, please use Excel. So then the last thing we have to do is come up with our conclusion and interpretation. So the conclusion, well, let me write this down first. That's wrong. Ignore that. The conclusion is going to be based on whether the p-value is less than our alpha. So for the conclusion, I'm going to ask a question. Is the p-value less than the alpha? If the answer is yes, then I reject the null hypothesis. If the answer is no, then I do not reject the null hypothesis. So if the p is less than the alpha, then that means the probability is too small to be plausible. So if p is too low, we reject HO. And this is the same question we asked no matter what our null and alternatives were. We always want to know, is the probability, is the p-value too small? So is 0.3085 less than 0.10? If you're not sure, you can use this trick. Start at the decimal point, underline numbers, and compare the numbers. Is 3 less than 1? No. And this is helpful when you have like a lot of zeros happening. So no, therefore we do not reject the null hypothesis. That's our conclusion. The second step to part 4 is to take this conclusion and write out an interpretation. We want our interpretation to be detailed and give context to the original problem. So I start all my interpretations by restating what my conclusion was. So we do not reject the null hypothesis and conclude. Okay, so this is what we've done. Now what are we concluding in context of the problem? So what is it that we were looking at? We are concluding that the proportion, we are looking at a proportion of Americans that smoke tobacco, again, be detailed. So the proportion of Americans that smoke tobacco has not decreased since 2010 from 20%. So the original problem, I'm going to scroll up, was a study that was reported in 2010 that said 20% of Americans were smoking tobacco. We were trying to prove that that had decreased. Our p-value was not small enough to prove that it has. Our results, 76 out of 400, were not so unlikely to say that that proportion has decreased. 19% is less than 20%, but it's not far enough away. It's not statistically significant. Okay, so we do not reject the null hypothesis and conclude that the proportion of Americans that smoke tobacco has not decreased since 2010. 2010 from 20%. That's one way you could do this. I am going to show you another way to interpret it. This is the way that my brain tends to want to write these interpretations, and it's not always the best way. And I'm going to be totally honest with you on that. And it's because of the not decreased and the not, and there's a lot of nots happening, and it gets confusing later on. So another way that you could write this interpretation, this is just an alternative method, is to say we do not reject the null hypothesis. And this second method is going to better match what you're going to see in your homework. And if you look in the textbook ever, it better matches what the textbook is. So we do not reject the null hypothesis and conclude that there is not sufficient evidence to suggest the proportion, again, this is wrong, of Americans that smoke tobacco has decreased since 2010 from 20%. And the reason why this second one is a little bit better is because it's saying we did not have sufficient evidence. So that's taking it back to the idea that a hypothesis test is similar to a court case. A p-value is the evidence that we need to reject the null. We did not have that evidence, so we are not rejecting the null. So this second one is actually probably the preferred one, or the preferred kind of type. The first one is that I wrote in green there is not bad, but again, as we look at more examples, it'll get a little bit so yeah. But again, as I read this, I don't see the word it. Okay, the place that you could say it suggests that it has not decreased since 2010. What is it? There's a lot of information that you leave out if you say it. Okay. Yeah. So that is the first example of how to do a hypothesis test. This was specifically an example of how to do a hypothesis test if the problem is left-tailed. That is specifically what we were looking at here.